Good morning. So, the series I have been assigned to teach is the Taylor series. The question at hand is finding the Taylor series generated by f at x equals a. The function is f of x is equal to 2 to the x at a equals 1. Okay, to start off, let me give you a general preview of the Taylor series. So the general formula of a Taylor series, as stated, is equal to f of x is equal to f of a, which would be your a from the question, plus the first derivative of a, times x minus a, plus the second derivative of a over 2 factorial times x minus a squared, plus the third derivative of a divided by 3 factorial times x minus a cubed. And as you can see, this follows the pattern of f to the n of a divided by n factorial times x minus a to the n. Okay, so keep this general formula in hand as it pertains to all series. Okay, moving back to our problem, we see that in the general formula you not only need f of a, but you also need f prime of a and f double prime of a. So by taking f prime of a and f double prime of a, we can use it to see the general pattern. And by seeing this pattern, we can develop the master formula for the particular series. Okay, so let's start off by taking the first derivative of the function. The first derivative of f of x is equal to 2 to the x follows one of the original calculus rules we learned in Calculus 1. The derivative of anything to the x is that number to the x ln of that number. So for our case, for example, f prime of x would equal to 2 to the x times ln of 2. Once again, as we had learned in Calculus 1, taking the derivative of as following the rules, as you take the second derivative of x, you would get 2 to the x ln of 2 squared. And this basically follows a basic formula that we learned in Calculus 1, where anything to the power is equal to that to the power ln of that number. Okay, so now that we have the first derivative and the second derivative, we're ready to move on to the general formula. Okay, so we know that a is equal to 1. So we can start off looking at the formula, and the first thing that we see is f of a. So we would plug in a directly into the original function. Plugging it into x, you would get 2 to the x. Now, what you would take is take your formula and you would take the f prime version. So as you can see, the derivative of the original function is 2 to the x ln of 2. And so f of a at this position would be plus, let's say, 2 to the x, which we're getting from over here, ln of 2. Sorry for my bad handwriting. And one thing you got to make sure you're looking at is in the general formula you have x minus a. So this is where your a comes in handy. So your formula would be 2 to the x for your first term. For your second term, you'd have 2 to the x ln of 2 times x minus your a, which is 1. And so now you have the first two terms of the series. Now moving on to the third term of the series, you see that you get the second derivative of the original function over 2 factorial times x minus a squared. Okay, so we see the second derivative to be 2 to the x ln of 2 squared. So writing that out, we get 2 to the x ln of 2, and once again, excuse my bad writing, x over 2 factorial, sorry, which is simply 2, times x minus your a, which is 1, squared. Okay, so now we have the first term, the second term, and the third term. Looking at this, we see a general pattern in the series forming. This general pattern, okay, as you can see, 2 to the x is constant, clearly, right here, and right here. But what is changing? As you see, the ln of 2 remains the same, but the power changes. This is to the first power, this is to the second power. Okay, that's one change. Keep that in mind. Also, you're noticing in the denominator, there's a 2 factorial. This is a 1 factorial, which you cannot see, but I'll just put it here as you can see. But as you see, the factorial is increasing by increment of 1. Okay, so keep that in mind also. The last thing we notice is that the x minus 1, the power is increasing over here. So okay, so these 3 things form the general formula for the series. Using these, we can predict what the general formula will be. Okay, so 2 to the x is a constant, so let's lay that down. 2 to the x. ln of 2 is also constant throughout the series. So let's write ln of 2. But one thing we did notice was that the power was changing. So, originally, we see as our first term, the ln is totally disappeared. So that can only mean that 2 to the x was multiplied by the number of 1. And in order to get 1 right here, you would have to have n minus 1. Your n being this 1 right here. Since 1 minus 1 cancels out to 0, anything raised to the 0 power is equal to 1. So 1 times 2 to the x leaves you with 2 to the x. So this sets up the power right here. Secondly, we also notice the factorial in the denominator. So, as you can see, originally, moving on from here, you see 1, 2. So clearly, all you need to know is that this is n factorial. Okay. So plugging this in, if you follow this, you get all the values above. Thank you.